Hello and welcome back at the FinetLink channel where we are configuring switch security to mitigate LAN attacks. And now we are at the part 2. For the first part, we implemented port security to mitigate MAC address table attacks. And now in this material, we will explain how to configure DTP and native VLAN to mitigate VLAN attacks, which mean dynamic trunking protocol. And we will explain how to configure DHCP Snooping to mitigate DHCP attacks, and then we will explain how to configure ARP Inspection to mitigate ARP attacks. And in the last and the third video, we will explain how to configure port fast and bridge protocol data unit guard to mitigate spanning tree protocol attacks. So let's dive in the 3 topics that we will study for today. Since we are mitigating VLAN attacks, as a quick review, we have to know that a VLAN hopping attack can be launched in one of those 3 ways. Spoofing dynamic trunking protocol messages from the attaching host to cause the switch to enter trunking mode, and from here the attacker can send traffic tagged with the target VLAN, and the switch then delivers the package to the destination, or by introducing a raw switch and enabling trunking, where the attacker now can access all the VLANs on the victim switch from the raw switch. And another way is a VLAN hopping attack, where is a double tagging attack. By this attack, it takes advantage of the way hardware on most switches operate. And the steps to mitigate VLAN hopping attacks are by following the steps that are listed in this slide. The first step is to disable dynamic trunking protocol auto-trunking negotiation on non-trunking ports by using the switch port mode access interface configuration command. The second step is by disabling unused port and then put them in an unused VLAN. And the step 3 is manually enable the trunk link on a trunking port by using the switch port mod trunk command. And the fourth step is to disable dynamic trunking protocol auto-trunking negotiation on trunking port by using the switch port negotiate command. And then at the step 5, we have to set the native VLAN to a VLAN other than VLAN 1 by using the switch port trunk native VLAN followed by the VLAN number. So let's get an example. Let's assume that we have those following. We have the fast Ethernet port 01 through fast Ethernet 016 as active access ports. We have fast Ethernet port from 017 to 020 that are not currently in use, and then we have fast Ethernet ports from 021 to 24 as a trunk ports. So the VLAN hopping can be mitigated by implementing those following configuration. So we will go to the interface range fast Ethernet 01 and 16. Since they are active ports, we are making them active by using the switch port mode access. And then, since ports from 017 to 020 are not currently in use, we will put them in another unused VLAN. So we go to these interfaces by using the interface range fast Ethernet 017 to 20. And then after we are entered in those interfaces, in this range of interfaces, we are making them as active. And then with the command switch port access VLAN 1000, we are sending them to the VLAN 1000. And with this command, we are even creating a VLAN 1000. And then those ports in this VLAN will be shut down. So we are exit from these interfaces, and now we have to go to the trunk ports, which means that we go to the interface range fast Ethernet 021 to through 24, and in this range of interfaces, we are turning them in trunk port, but we will disable dynamic the trunk port auto trunking negotiation by using the switch port negotiate. So we say this port will be switch port mode trunk, so will be trunk ports, but we will disable dynamic trunking protocol, which means we are disabling auto trunking negotiation on those ports by using the switch port non-negotiate. And then we are even set the VLAN native as different from VLAN 1. So by using the switch port trunk native VLAN 999, we are creating a native VLAN different from VLAN 1. And here, with this configuration, the Ethernet ports from 01 to 16 now are access port, and therefore trunking is disabled by explicitly making them as an access port. And from fast Ethernet 017 to 20, now they are unused port and are disabled and assigned to an unused VLAN. And from Ethernet to fast Ethernet 021 to 24, now they are trunk links and are manually enabled as trunk with dynamic trunking protocol disabled, and the native VLAN is also changed from the default VLAN 1 to an unused VLAN 999. Now we are mitigating DHCP attacks. As first, we have to do a overview. So the goal of DHCP starvation attack is to create a denial of service for connecting clients. DHCP starvation attack require an attack tool such as Gobbler. Recall here that DHCP starvation attacks can be effectively mitigated by using port security because Gobbler use a unique source MAC address for each DHCP request sent. However, mitigating a DHCP spoofing attack requires more protection. Gobbler could be configured to use the actual interface MAC address as the source Ethernet address by specify a different Ethernet address in the DHCP payload. And this would render port security ineffective because the source MAC address would be legitimate. And the DHCP spoofing attacks can be mitigated by using DHCP snooping on the trusted ports. So what is a DHCP snooping? A DHCP snooping does not rely on source MAC addresses. Instead, DHCP snooping determines whether DHCP messages are from an administratively configured trusted or untrusted source. It then filters DHCP messages and rate limits DHCP traffic from untrusted source. Devices under your administrative control, such as switches, routers, and servers, are trusted resources. Any device beyond the firewall or outside your network is an untrusted source. And in addition, all access ports are generally treated as untrusted sources. And this figure here shows an example of trusted and untrusted ports. Okay, so you can see here that the route DHCP server would be an untrusted port after enable DHCP snooping. All interfaces are treated as untrusted by default. Trusted interfaces are typically trunk links and ports directly connected to a legitimate DHCP server. These interfaces must be explicitly configured as trusted. A DHCP table is built that includes the source MAC address of a device of an untrusted port and the IP address assigned by the DHCP server to that device. The MAC addresses and IP address are bound together, and therefore this table is called the DHCP Snooping Binding Table. And there are some steps to implement this DHCP snooping. The first step is to enable DHCP snooping by using the IP DHCP snooping in global configuration command. And then in the second step on the trusted ports, we use the IP DHCP snooping trust interface configuration command. And at the step 3, we limit the number of DHCP discovery messages that can be received per second on a trusted port by using the IP DHCP snooping limit rate in the interface configuration as a command. And at the step 4, we enable DHCP snooping by VLANs or by a range of VLANs by using the IP DHCP snooping followed with the VLAN in the global configuration as a command. So let's get an example to configure the DHCP snooping. We will use a reference topology for the DHCP snooping example as it is shown here in this figure. Here we see that fast Ethernet 05 is an untrusted port because it's connected to a PC, and meanwhile fast Ethernet 01 is a trusted port because it connects the DHCP server. So here are the trusted and untrusted ports. And in this example, we will show how to configure DHCP snooping on the switch 1. You will see that DHCP snooping first is enabled. Then the upstream interface to the DHCP server is explicitly trusted. And next, what we will do at the range of fast Ethernet ports from fast Ethernet 05 to 24 are untrusted by default. So rate limit is set to 6 packets per second. And finally, the DHCP snooping will be enabled on VLAN 5, 10, 50, and 51, and in 52. So how we will do that? So first thing in the global configuration command, we will enable DHCP snooping by using the IP DHCP snooping snooping command. And then we will go to the interface fast Ethernet 01, where we are configuring that as a trusted port. So by using the interface fast Ethernet 01, we are going to the interface fast Ethernet 01, where here by using IP DHCP snooping trust, we are configuring this port as trusted. And then from the fast Ethernet 05 to 24, we will limit the number of DHCP discovery messages as 6 here by using the IP DHCP snooping limit rate 6. And then what we do, we will enable DHCP snooping by VLANs here. By using the IP DHCP snooping VLAN, we are enabling that for VLAN 5, 10, and 50, 51, and 52. If we want to see the configuration that we have done by using the show IP DHCP snooping and the privilege access as a command to verify the DHCP snooping, and by using the show IP DHCP snooping binding, we can view the clients that have received DHCP information as it is shown here. This is the binding table, and it shows the MAC address of the device that is connected. And that device is the PC1 that is connected through the interface past Ethernet 05 regarding to our reference topology of example. Now we are investigating the ARP attack, and this is the third part for this video. And let's do a review where we know that in a typical ARP attack, a threat actor can send unsolicited ARP requests to other hosts on the subnet with the MAC address of the threat actor and the IP address of the default gateway. And to prevent ARP spoofing and the resulting ARP poisoning, a switch must ensure that only valid ARP requests and replies are relayed. The dynamic ARP inspection requires the DHCP snooping and helps prevent ARP attacks by not relying invalid or gratuitous ARP requests out to the other ports in the same VLAN, intercepting all ARP requests and replies on untrusted ports, verifying each intercepted packet for a valid IP to MAC binding, and dropping and logging ARP requests coming from invalid sources to prevent ARP poisoning. And the last is error disabling the interfaces if the configured dynamic ARP inspection number of ARP packets is exceeded. And we have an implementation guidelines for dynamic ARP inspection. Because to mitigate the chances of ARP spoofing and ARP poisoning, we have to follow these guidelines. So we have to enable DHCP snooping globally on a selected VLANs. We have to enable dynamic ARP inspection on the selected VLANs, and then we have to configure trusted interfaces for DHCP snooping and ARP inspection. And it is generally advisable to configure all access switch port as untrusted and to configure all uplink ports that are connected to other switches as trusted. And here we have a sample topology where it identifies trusted and untrusted ports. And as you can see, switch 1 is connecting 2 users on VLAN 10. Dynamic ARP inspection will be configured to mitigate against ARP spoofing and ARP poisoning attacks. And as it is shown here in this example, DHCP snooping will be enabled because dynamic ARP inspection requires the DHCP snooping binding table to operate, and then DHCP snooping and ARP inspection are enabled for the PC on the VLAN 10. And as you can see here, we do the IP DHCP snooping globally, so we are configuring this globally. And then we enable DHCP on the selected VLAN, which means for the VLAN 10. And then by using the IP ARP Inspection VLAN 10, we are configuring the ARP Inspection. And as for the uplink port that is connected to the router, it will be trusted, and therefore the fast Ethernet 024 will be IP DHCP snooping as a trust and as IP ARP inspection as trusted. Dynamic ARP inspection can be configured to check for both destination or source MAC address and IP address. For the destination MAC address, it checks the destination MAC address in the Ethernet header against the target MAC address in the ARP body. For the source MAC address, it checks the source MAC address in the Ethernet header against the sender MAC address in the ARP body. And as for the IP address, it checks the ARP body for invalid and unexpected IP address, including addresses as 0.0.0 or 25.25.25.25 and all IP multiple addresses. The IP ARP inspection validated in the global configuration as a command is used to configure dynamic ARP inspection to drop ARP packets when the IP address are invalid. It can be used when the MAC addresses in the body of the ARP packets do not match the addresses that are specified in the Ethernet header. Here in this example, we will see how only one command can be configured. Therefore, entering multiply IP ARP inspection validate command overrides the previous command. To include more than one valid method, you have to enter from them on the same command line as it is shown here. So that should be valid. So we have to validate the IP address and the source MAC address. But if you do them in different lines, they will override the comma that is used before. So we have to write them in one line. So here we are validating source MAC address, destination MAC address, and the IP address. And that's is all about the second part of configuring switch security for mitigated LAN attacks, where we mitigated VLAN attacks, DHCP attacks, and ARP attacks. And in the third video, we will mitigate spanning tree protocol attacks. Thank you all for being here with us at this channel. And for those who are new, do not forget to subscribe to this channel and hit the notification button for the new videos that will be uploaded. If you like the video, share it with your friends. See you in the next session.